Welcome learners, this is Mr. Odingo here. Today I want us to move forward to be able to understand electrons and how electrons are arranged in their energy shells. So without wasting time, today I want us to talk about electrons. And quickly, we have known that there are three subatomic particles: electrons, protons, and neutrons. Initially, in the previous lessons, we were able to look at the mass numbers, atomic numbers. That was mainly about the contents of the nucleus. Today, we want now to look at the energy shell. We agreed that there are two parts of an atom. One is the nucleus, and another one is the energy shell. So today, quickly, we have to I have to bring this to your attention, that the number of electrons and protons must always be equal. So number of electrons equals number of protons in any atom. Number of protons. This argument is true only for an atom. For ions, that's not the case. But today we are still looking at an atom. So in any atom, we have to be agreeing that the number of electrons and that one of protons will be equal. For example, sodium has 11 protons, and as such, 11 electrons. So those numbers must be equal. And we know that protons or electrons here are negatively charged, and these ones are positively charged. So we can actually say that an atom is actually neutral. It was what we call neutral. Why is it neutral? Not just neutral, but electrically neutral. Electrically neutral. It means that an atom is neither positive nor negatively charged. That's what I mean by electrically neutral. Why? Because an atom has equal number of protons and electrons. Viewer, after understanding the relationship between the number of electrons and protons in an atom, I want to invite you to move further to see how are electrons arranged in the energy shells. So we want to talk about arrangement of electrons inside the energy shells. Arrangement of electrons. Arrangement of electrons in the energy shells. And learners, this is a very important point, because this is where we actually begin to understand chemistry, because it is from this point that we are going to understand how many electrons are lost or how many electrons are gained. So viewers, quickly, I want to draw a cycle, and not just one cycle. There are going to be concentric cycles that some are inside others. And I will start by drawing a smaller cycle, then another bigger cycle, then a second bigger cycle. So here, this nucleus here, let me shade it. This is what I'm going to refer to as nucleus. And right now we know what is found in the nucleus. There are protons, and electrons. Those are the subatomic, protons and neutrons, protons and neutrons. Those are the subatomic particles that are found inside the nucleus. We agreed initially that the electrons are found in the energy shells. So the energy shell, this could be the first energy shell here. This one is the second. And we can have the third, depending on how many protons or electrons that particular atom has. Now, when we are filling, we don't just fill like the nucleus in the atom, the nucleus of an atom, we just have protons and neutrons there. We don't really study how they are arranged. In the energy shell now, we have to dig deeper to understand how electrons are arranged in the energy shell. And this one will depend on a few guidelines. And because we are going to look at the first 20 elements only, these rules may change. So we are going to concentrate on the first 20 elements only. And for the first 20 elements, I want us to see that every time we are filling the energy shells, it's like filling shelves in a shop. If you have ever visited a shop, these shelves are not actually those ones of a shop. But I want you to invite you to understand that the shelves, we can have a shelf, maybe a lower shelf, an upper shelf, like that. As we continue going, these shelves become bigger. And we have to agree that for us to fill the upper shelf, this is the first shelf, the second one, the third, the fourth, the fifth, as we go on. Let me remove the fifth so that we just have 4 energy shells. You realize that this energy shell, the first one, is smaller, and we are filling it, assuming we are filling with bread, loaves of bread. So we can actually say that the first shelf here can only carry loaves of bread. Let me use crosses to represent the loaves of bread here. So before the first energy shell or the lower energy shelf can be filled, the second one can be filled. I have to fill the first one first. So I cannot start filling the second energy shell before filling the first one. So assuming the first one can only be filled with 2 electrons or 2 loaves of bread. Then I move to the second one, the second energy shell here, or the second shelf. I'll bring in 8. 8, those are 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. So I can say that this shelf here will be filled by a maximum of 8 loaves of bread. Once I fill that second shelf, I will go to the third. The third also must be filled by a maximum of 8. 1, 2, 3, 4, 5, 6, 7, 8. Now, for the first 3 shells, I can see that for them to be maximally filled, I have 2 loaves of bread. I have 8 loaves of bread. Then I have another 8 loaves of bread. For me to, if this one is filled by 8 loaves of bread, I cannot add the 9th one here. I cannot add the 9th one here, or I cannot add the 3rd one here. Meaning the 2 is the maximum number for the first shelf. 8 is the maximum number for the second shelf, and 8 is the maximum number for the third shelf. If I have to go to 9, then that one remaining, I have to bring it to the 4th shelf. Viewers, that is exactly what you want to apply here. That when we are filling the energy shelf, the energy levels or the energy shells, we have to first of all fill the lowest energy shell, which in this case is the first energy shell here, and the number there must be 2. The number of electrons that can maximally fill that energy shell is 2, meaning it can fill 1. We can have actually 0 electrons there, but we cannot have more than 2. Any extra number of electrons that remain after filling the first energy shell, we have to carry it to the second energy shell, which I said, according to what I've actually illustrated here, that the second energy shell must carry a maximum of 8 electrons. 8 electrons. 8 electrons there. This one I've said is 2 electrons. 2 electrons. So we have the first energy level will carry 2 electrons. The second will carry 8 electrons. If we have the third, for example, we have to go for the third energy level. And the third energy level, viewers, will also carry 8 electrons maximally. When I say maximally, what I mean is that this energy shell can carry 8 or less, but cannot carry more than 8. So viewers, these are very important rules that we have to really use to guide us when we are actually determining the number of energy shells that an atom has. For example, if we have an atom like sodium, if you have sodium atom, sodium we know is number 11 in the periodic table, meaning it has 11 protons. And we said 11 protons, meaning that it must also be having 11 electrons. 11 electrons, because it said the number of protons and electrons are equal. So if we have 11 electrons to distribute, we have to start filling our energy shells from the lowest. We fill the lowest, we go to the second lowest, like that until we reach the last energy shell that can be filled. So the first energy shell here, we say it can carry 2, maximally 2 electrons. So I'll bring 2 electrons and I use crosses here to represent those electrons. After I fill 2, I had 11 initially. How many remaining? This will be 9 electrons. 9 electrons, I move them to the second energy shell here. And in the second energy shell, we said it can carry a maximum of 8 electrons. So we'll fill 8 here. 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. 8 are filled. The second energy shell is completely filled. The first is completely filled. So if I subtract 8 here, how many electrons are remaining? We are remaining with 1 electron only. Viewers, we cannot say 1 is not really big. Let's fix it here so that's 9. A rule is a rule, we have to follow it. So that 1 electron that remains, we are actually carrying it to the next energy shell, which is going to be there. So this is how an atom of sodium is, how electrons are actually arranged in this particular atom. Viewers, thank you, and welcome next time. For notes or question papers, please try to download and then subscribe so that we can be able to support us in this program. Thank you.